Hi, welcome all to the next video on organic chemistry. In this series of videos, I'm explaining to you on how to predict the products for various organic reactions in a much easier way. The organic chemistry is based on pure logic. So, if you can understand the logics of how to predict the products, there are some tips and tricks that I will give you. If you watch those tips and tricks and if you apply to any reaction in the organic chemistry, you will be able to answer the questions asked in organic chemistry. You will be having basically 4 types of questions in organic chemistry. The first one will be they will ask you to predict the products for any reaction. So, the second one will be the conversion problems, like convert 1 propanol to 2 propanol or methanol to ethanoyl or something like that. So, conversion problems. And the third one is the naming reactions like Friedel-Crafts alkylation, Reimer-Tamer reaction, Williamson synthesis, etc. And the fourth one is the test to distinguish between the various compounds that is being given in your NCERT syllabus. So, basically all these reactions involve the same logic which I am going to teach you in my video. So, if you watch all my videos, then you will be able to see how that same logic is applied to various reactions, and you will be able to easily predict the product. Come, let's go to the video. So, the first tip that I gave you in my video is the organic schema, where you have to generate plus minus in the reactant and reagent. For those of you who didn't watch, I will just give you a quick recap of that. So, you have a reactant, then you have the reagent, sometimes they will give you a solvent, and then you have the intermediate which has to be stabilized by one of the 7 effects, and then you have the leaving group which goes to form the products. In the reactant you have to create a plus minus, and reagent you have to create a plus minus. The intermediate, as I told you, has to be stabilized by one of the effects like resonance, hyperconjugation, aromaticity, hydride shift, methyl shift, steric hindrance based on that, and then ring expansion and the inductive effect. So, mostly the carbocation stabilization will be the asked in your intermediate stabilization. In some rare reactions you will have the carbon ion stabilization. So, in the previous video we have been watching on how to predict the products using the Grignard reagent. So, Grignard reagent, as I told you, is a versatile reagent where you can use to predict or convert any compound to any compound using the different types of Grignard reagent. Let us see some more reactions of Grignard reagent in continuation with the previous video, applying the same organic schema logic. So, suppose if you have a question like this, CO2 plus CH3 CH2 MgBr followed by A followed by B. So, if this is the question that is being asked, then you have to apply the organic schema. So, first you have to draw the structure of the compound in order to predict the product. So, carbon dioxide is a linear molecule with a net dipole moment 0, and you have this ethyl magnesium bromide. So, you have to create plus minus and plus minus here. I have already told you how to create plus minus in various reactions. So, here whenever you have this type of compound, you will have plus minus like this. So, this plus and this minus will go and attach like this. So, if you see that here you will have 0 O double bond C. In this you will have the C2H5 is getting attached here, C2H5 is getting attached here, and then here you will have the O, you will have this OMgBr will be attached here. This will be the intermediate. This need not be stabilized in this case of reaction. Only the carbocation and the carbon ion needs to be stabilized. These are all tips and tricks. Remember, they are not rules like, so you have to follow it in that pattern. So, again you have to create a metal plus and oxygen minus. So, this bond will break. In the next step you will have the hydrolysis in the presence of a dilute acid. So, again you have the plus minus as I told you here. Then attach the plus to the minus and minus to the plus. So, you will have the byproduct that is coming out MgOH and Br, and the product is, so you have O double bond C, you have C2H5, and then here you have OH. So, basically this is propanoic acid. So, by following this organic schema, you can predict the product of any reaction using the by the tips and the tricks that I gave you here, generating this and attaching this. If needed, you need to stabilize the carbocation or carbanion, and then you have to go for the product. So this is one of the another versatile reagent. So now let us see some more reactions based on Grignard reagent. So if you take, say for example, instead of carbon dioxide, if you take water, H2O, and then suppose if you add, say, methyl magnesium bromide. So usually this will be having a two-step reaction. The first one in the presence of dry ether as the solvent. Okay, now here if you see, as I told you, again H plus and OH minus and Mg plus and CH3 minus. Remember, you need to give a charge to carbon always in any organic reaction, because sometimes you may have another atom or another functional group which may also tend to carry a negative charge or positive charge, but you always have to give a charge to the carbon in the case of organic chemistry. That is another small tip that you need to remember regarding predicting the product of any reaction. Again, you apply the same logic. So the minus will go to plus and the plus will go to minus. Simple reaction. So you don't have to wait for any other reaction. There is no intermediate in this step, so directly the compound is formed. So you have the CH4, that is methane is formed here. So methane is formed in this reaction. So by just following the logic that is given here, we can predict the product of any reaction, any organic reaction. So you need to know how to generate plus minus and plus minus in the case of reactant and reagent. That is the crucial step. It's very simple. By practice you will be knowing how to generate plus and minus, like in the case of carbon dioxide we saw and in the water we saw. Let's take one more example. Say for example, if you take ammonia and then if you add, say, CH3MgBr. I will take a simple Grignard reagent for all purpose. So you can, this R group can be varied. You can have any R group here. You can have ethyl, methyl, isopropyl, tertiary butyl, any alkyl group you can have. You can also have aromatic groups like benzyl or phenyl or any group that you can have. That group will be incorporated into the reactant. Okay. So this is the reagent and this is the reactant. So how to generate plus minus here? So regarding ammonia, you need to know that whenever you have ammonia, ammonia can be dissociated to produce like this, H plus and minus here, and again this NH2 minus can be dissociated to produce NH minus plus H plus. You will have two more, you will have this getting broken down into, so each hydrogen can be replaced, and these are all the nucleophiles. So you will have N2 minus and N3 minus. You will have the third hydrogen that is coming up from this. So all these are all nucleophiles. So this is how you generate plus minus here. So in this case now, if you generate a plus minus like this, NH2 minus and H plus, so you have this is minus and this is plus. So you will have this coming getting attached here, this coming and getting attached here. So what will be the product? The product will be Mg. This Mg, this NH2 will come and get attached here, and you will have the Br here, and then this CH3 will get come and attached to this compound plus CH4 that you will get. So like this you can predict the product of any reaction. Suppose if you take, say, acyl chloride in the presence of, say, CH3MgBr. So you need to be little careful in predicting the plus minus in the case of reactant and the reagent, because not all the reactions will have the same logic that is getting applied. There are one or two variations. In 99% of the reactions you will have this plus minus generation based on, I have explained you in the first video, but in some cases, like in this case for example, if you take this here, generally we tend to put like this. So but this is not the way you should put. So this is not the way you should put, because this bond doesn't break here, but this bond breaks here. So this bond, so this will have minus and plus like this. Okay, so here you will have plus and minus. So this plus will come here and this CH3 will go here. So you will have the product that is formed will be, so you have CH3, C double bond O, and then you will have this CH3 coming and getting attached here, plus this MgClBr. MgCl and Br. So you get a ketone. So if you take a acyl chloride, you get a ketone. So in predicting the products, you can always have this type of reactions using the Grignard reagent. So by changing, as I told you, by changing this group, you can get any compound here. You can prepare any ketone, you can convert any acyl chloride to the corresponding ketone. So preparation of ketone. So instead of studying chapter wise, say for example you have the haloalkanes and haloarenes chapter and amines chapter and aldehydes, ketones and carboxylic acids and alcohols, phenols and ethers. Instead of studying chapter wise, if you know how to predict this product, because in the exam you will not be asked questions on chapters like, they will be simply asked questions. So when you are asked questions, you should know how to attack the questions. Okay. So this is another way of predicting the product using this. So similarly, if you take, say for example, Grignard reagent plus, say if you take KCN, remember this is an ionic compound. This is an ionic compound because K is more electropositive element and Cn minus will be the nucleophile. So again you will have plus here and then the minus here. So plus here. So this minus will come and get attached to this and K will get attached to this. So this cyanide. Okay, so let me take another example. So this will not work properly. CH3Cl plus KCN, if you take like this, very simple. If you can take like this, so you will have CH3 plus and CH3 minus here. So this will come and get attached here. So you will have CH3Cn plus KCl. But if you take AgCN, this is a covalent compound. Here the lone pair in the nitrogen will act as a nucleophile, the electron donor. But here in this case, Cn minus, which is ionized, will be the electron donor, which will act as a nucleophile. Here carbon will act as a nucleophile. Here nitrogen will be the point of attachment of this nucleophile. So we call them as amphident nucleophile. So amphident nucleophile is same nucleophile. In one compound C will get attached, in another compound N will get attached. So you have two types of attachment depending upon the type of compounds that you have. Therefore this is called as an amphident nucleophile. So here if you add Cn, you will have CH3, actually it will be NC plus you will have the AgCN. So, but for all practical purpose, we say that both of them are cyanide. So, this is cyanide, this is isocyanide. Okay. So, like this we can predict the product of any reaction by simply following the organic schema. Now, the next tip is when a system contains two acids, that is in a reaction, if you are given two acids, the stronger acid will protonate the weaker acid. Okay. For example, if you take benzene or any compound, you take benzene and then you will have the H2SO4 bar HNO3. So now this is, you know that sulfuric acid is a strong acid. This is comparatively a weaker acid when compared to sulfuric acid. So this will protonate the weaker acid. So let me show you how this reaction actually happens here. So when the sulfuric acid, this will dissociate. So this will dissociate to produce H plus plus HSO4 minus. So this proton will go and attack the nitric acid. So you will have the HNO3. You will have the HNO3 like this. So oxygen will have two lone pairs here. This proton will come and attack this here. So this will try to form a covalent bond here. Coordinate bond will be formed in this position and oxygen has lost its lone pair, it will develop a positive charge. So oxygen being the second most electronegative element, it cannot hold the positive charge, therefore it has to break a bond. So it cannot break this bond or this bond because that will again result in the formation of nitric acid. Therefore this bond will break, resulting in the water will be a very good leaving group, thermodynamically stable leaving group, it will go out, resulting in the formation of NO2 plus electrophile. So this is the electrophile that will be generated. So as I told you, following the organic schema, in the reagent you have to create plus minus, but apparently if you look here, you should not generate plus minus like this because these are all dissociated compounds. When you generate plus minus, both the plus and minus should be residing in the same compound. It should not break into two parts or two ions or something like that. So when you add these two, you have the nitro electrophile that is getting generated. So you have the product as nitrobenzene. Since all the carbon are same, it can go and attack on any carbon and it can form the some bond over there. So you will have the nitrobenzene here, and once the nitrobenzene here, in the final step H plus will be released. So this H plus can combine with sulfuric acid to form sulfuric acid again back. So again this sulfuric acid will dissociate, this will protonate the nitric acid, then it will generate this nitro plus. So this nitro group will come and attack the benzene. So this reaction will go on forever like. So this is a very strong nitrating mixture. Okay. So this is how you use this organic schema to predict the product of any reaction. Okay. So in this video, so we have seen how some of the reactions of Grignard reagent and how when a system contains acid, how does the acid will behave and it gets converted to an electrophile. So in the next video, we will be seeing how a nucleophilic reaction, substitution nucleophilic reaction takes place. We will apply the same organic schema and try to predict the products in substitution nucleophilic reaction, that is SN1 and SN2. So I have given the notes for this topic in the description below, and I also given the online test for on this general organic chemistry on predicting the products in the test below. So please do take the test, and if you have any comments, any suggestions on this video, please do it in my comments box and suggestion box, which will help me to improve my video and the quality of the video. Thank you for watching.